Hi, in this online lecture we're going to be looking at how you can look at an incomplete simple reaction and predict what is going to happen. So one of the simplest types of chemical reactions is called a single replacement reaction. And it usually follows the same pattern in that there is a lone element, we'll call it A, and it's reacting with a compound, we'll call it X, Y. And what happens is that A will take the place of one of the two elements in the compound. So what will happen is, let's say A takes the place of X in the compound with Y. That means that X is going to be out here all by itself. And so you get X and AY. This is called a single replacement reaction, and it follows this pattern pretty closely. So let's get into some specific examples. You could have, say, potassium reacting with iron sulfate. So where does the pattern, how does this pattern apply? Let me show you where the A, X, and Y are at here. We'll say that A is red. We'll say that X is green, and we'll say that Y is blue. So A in this pattern would be potassium, X in this pattern would be the iron, and then the Y would be the polyatomic ion sulfate. And so the most important thing to remember for this pattern is that like will replace like replace like. So potassium, the lone element, is a metal, so it's going to take the place of the metal in the compound, and the metal in this compound is iron. So potassium is going to take the place of the iron, and so you're going to, an iron is going to get kicked out and be all by itself. So you're going to get iron by itself and potassium sulfate. Notice I put a little 2 there. You should be able to figure out why that 2 is there by now. And that's basically how it works. If you have the beginning of a single replacement reaction, you should be able to predict the products. Also, if you have the products, you should be able to predict back the reactants. So say I had copper and sodium. Well, we'll just say sodium chloride. If those are the products, you can work backwards and try to predict the reactants. So copper would be like the X, the silver would be like the A, and the chloride would be like the Y. Remember, like replaces like. So sodium, copper are metals. Those are the two that are going to be swapping places. So if these are the products, then what did you have at the beginning? Well, you had sodium by itself reacting with copper chloride. Now, sometimes it's maybe not quite as cut and dry, and one of those examples is when you have highly reactive metals like sodium or potassium, we'll go back to potassium, reacting with water. It's not as clear what's going on here. And what happens is the potassium is going to kick out some hydrogen, which will be H2, and then what's going to be left, actually one potassium kicks out one hydrogen, and then it will ionically bond to the hydroxide polyatomic ion that's left. So that one's a little bit more confusing, but that's exactly what happens. The potassium kicks out a hydrogen and sticks to the hydroxide that's left. And this isn't balanced, and that's okay, but that's why it might be confusing. Well, if it kicks out only one hydrogen, why is it H2 there? Because what actually happens in this is that you have 2 potassiums, and then that makes 2 potassium hydroxides, and it reacts with 2 waters. But balancing is something for another day. I just wanted to show you the pattern of almost any reactive metal from groups 1 and 2 can do this. Some do it better than others, but calcium does it. It makes hydrogen and calcium hydroxide. So you should probably be aware of that because it's kind of an exception to the simplest part of the pattern. But that's predicting simple single replacement reactions. As always, if you have any questions, feel free to ask in class, and thanks for watching.